So, hello guys, with the name of God Ram Ram. I am Kumar K. Previously, I have worked at Amazon and Media.net as a software engineer, and now I'm here for you to solve this very difficult Amazon SDE-2 online assessment problem, which was asked for a CTC of 85 lakh rupees, a very hard DSA problem. It was just asked few days back. You can see in the lead code discuss post as well. Okay, really nice, really interesting problem. Okay, so even Chat GPT, AI, DeepSeek, good versions of them were not able to solve this problem. You can see I have those tabs open of DeepSeek and Chat GPT. So you are left alone to solve this problem. If you cannot do it, you will not get 85 lakh rupees in your bank account. So this is a very hard DSA problem. It involves bit manipulation. So directly let's jump to the problem. As we can see in the pic that the engineers at Amazon are developing a new rating system. You can see so many things here, right? You need to have the habit of reading large English paragraphs and analyze them so that you can begin to solve the problem, because many people get stuck in this part only and give up. So don't give up. So guys, basically an array is given to you. Okay, I will make it shorter for you. So basically an array is given to you of size n. Okay, now from that array of size n, what you have to do is find a subset of size m whose bitwise and value is g, and g should be as big as possible. Okay, so guys, you have to find a subset of elements and you have to calculate its and value, bitwise and it should be as big as possible. Before doing this, guys, the complication is that you are allowed to do at most k special operations. At most k special operations. Let me. So, guys, just stay focused. Okay, you have to do k special operations. Okay, you can select any number and increase it by one in the array in one operation. That's it. Size of the array is till 10 raised to 5. Customer rating can be till 10 raised to 9. K will be from 1 to 10 raised to 9, and M, the size of the subset which you have to select, will always be less than equal to n and greater than equal to 1. Okay. So, guys, you need to do some prerequisites before you start solving this problem. The first prerequisite, which is again very important, you need to complete my prerequisite course, guys. If you're trying to prepare for any type of top product based company and you want to master your DSA so you can solve medium hard questions of lead code, GFG, and code chef code forces contest and OAs, please do this free course of mine from top till the bottom. Okay, please do this. If you do this, you will understand the hard level concepts I'm teaching in this video. Next thing, guys, you need to have a mastery on bit manipulation. Okay, many people just do standard DSA sheets and standard problems of bit manipulation, and then they screw up when the 85 lakh opportunity comes in their hand. So don't screw up, please don't screw up. What will you do? I have made a very good bit manipulation playlist. Okay, it covers many different tricks for the exact questions which were asked in FANG OA, CP, and FANGM interview problems. Please do them. It will take 5 to 10 hours, but do them. It is worth 85 lakh rupees for you if you are giving this OA of SD2 in Amazon. Okay, so please go ahead and do it. Once you do all that, now you can come to this question. So I will just make you do little bit of revision. So guys, see, this is called as binary number and that is called as decimal number. Okay, one looks like this in decimal and this is binary. Okay, one looks like this, two looks like this, three looks like this, and four looks like this, and five looks like that. Okay, and guys, for the and, the rules are 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0. Okay, so if I give you two binary numbers, you can, their value would be something in decimal, but in binary you have to solve them column wise. What is the and of 0 and 1? What is the and of 0 and 1? And of 0 and 1 is 0, so see the answer is 0. 1 and 0, 0. 0 and 1, 0. 1 and 0, 0. So you can see the final answer is 0, 0, 0. Here 0 and 0, 0. 1 and 0, 0. 0 and 1, 0. 0 and 0, 0. 1 and 1. Only when both the numbers are 1. This is decimal, this is binary. Only when both the numbers are 1, the answer is coming 1 here. Okay. Okay, sir. So, how will you choose a subset of size m so that the work gets done? So, for example, before I go towards the example, you can see this number, right? This is the binary number. How will you convert to decimal? 0 index, 1 index, 2 index, 3 index, 4. This is called as the most significant index. Okay. Like most significant index is not 4, sorry, it is the leftmost value where 1 was coming. So at 0th position 1 is there, it will give contribution of 2 raised to 0, and 3rd position 1 is there, it will give contribution of 2 raised to 3. Others will give no contribution. So answer will be 2 raised to 3 plus 2 raised to 0, which is 8 plus 1, which is 9. So 1001 is nothing but 9 in decimal, and this is binary 010001. Okay. So now let's go to the question itself. You can see that they have given 1248 to you. 1248. They are saying that select a subset of elements. Subset means select any two elements from this array, and their AND value should be maximum. Their bitwise AND should be maximum. So what the question is doing, it is selecting 4 and 8. So if you select a subset of size 2, which is 4 and 8, this is the subset which you have selected, right? Yes, sir. So what is the AND of 4 and 8? 4 and 8 is 0, guys. Why? Because 4 looks like this, 8 looks like this, right? So 0, 0, 0, 1, 0, 0, 1, 0. So 4 and 8 is 0. Then how can this subset have maximum AND value? Well, you are allowed to do 10 increment operations or 8 increment operations. It is given in the question that you can do 8 increment operations. So what you will do is you will increase this 4 to 10 by doing plus 6 operations, and this 8 to 10 by doing plus 2 operations. So plus 6 plus 2, 8 operations done. This is 10 10. So now your subset looks like 10 comma 10, and the AND of 10 comma 10 is 10. So guys, now you understood the best way to select a subset of size m where m is 2 is 4 comma 8. Why? Because after selecting 4 comma 8 you can do 8 increment operations, at most 8 increment operations like that, and the values become 10 10, and now that end is 10, so 10 is the final answer. But guys, how do we proceed to solve? You need to know some OACP tricks of bit manipulation. That's it. If you are my student who has done the bit manipulation 50 to 100-hour course, you will know what to do. Okay. And even if you are someone who is watching my YouTube videos since years, you will still know what to do. Okay. You can go into wrong approaches like binary search and all that. It is not going to work because the function is not monotonic. It is for the people who are trying to think of binary search here. Okay. And even ChatGPT DeepSeek gives the wrong answer unless you know and analyze properly. Okay. Now, listen, listen, listen carefully. Okay. See, my students have been doing great. Okay. Recently, one of my student has cracked Google plus Amazon SD internship at both the companies. One more student of mine has cracked off-campus Amazon SD internship. One more student. This all has happened in last 5 to 10 days only. One more student has cracked 51 LP off-campus SD offer from Amazon. One more student of mine has cracked 25 LP off-campus programmer analyst offer. Okay, guys, please read this paragraph. This is very important for you. Yeah, I got All India rank 7 in Meta Hacker Cup PRC round. In the recent Meta Hacker Cup round 2 as well, I got All India rank in top 300s. I will be getting a t-shirt from Meta Hacker Cup. I'm so happy. Now, guys, if you are interested in getting personalized one-to-one mentoring from me so I can resolve your issues, and you want a day live training, depending on your current DSA level, you might be beginner, intermediate, or advanced. So there are different codes for different people for DSA OECP day live training, one-to-one mentoring, and they want their improvement in full stack development, system design. They want off-campus job search training, LinkedIn training, resume training, many things like that we do for our students so they can get selected. And that's why I take very less number of students, okay, because providing one-to-one mentorship and daily taking the updates of student and keeping a track of them and knowing their problems on a daily basis, resolving them takes too much time. If you're interested to be the part of our journey, you can check this link. I'm not sure if seats will be available because manager allows very few people. Still, you can check it out and you can check. Okay. Now, listen to me very carefully. Think for 1 to 2 minutes about the solution of this problem. You can do it. Do not give up. Think about it. In every ingoing and outgoing breath, you have to take the name of God, Ram Ram, like this. This will lead you to ultimate moksha and amar lok. So never forget to focus on God. Please make God the center of your life. Now, think about the problem as well. So, guys, the trick is that you will think in terms of vertical columns. Think of the worst case. All the array numbers can be as big as 10 raised to 9. 10 raised to 9 can be represented in 30 digit binary numbers, right? 29 digit binary numbers actually. And even if you're allowed to do 10 raised to 9 operations, then also the final end of any subset will be less than equal to 2 raised to 31. So what I'm trying to say is that let's say this is an array given to you, right? The size of the array is 10 raised to 5. Let's say each and every element is as big as 10 raised to 9. Okay. So 10 raised to 9 is nothing but 2 raised to 29. Okay. Like a number as big as 10 raised to 9 can be represented as a power of 2 into 2 raised to 29 plus minus some numbers. Okay. Because 2 raised to 29 is very close to 10 raised to 9. Okay. So every number will be like this, okay? Okay. Now let's say someone is saying that you can do 10 raised to 9 operations, which means what? Which means that you can do maximum 2 raised to 29 operations. So if you do 2 raised to 29 operations here, 2 raised to 29, okay, and you again do 2 raised to 29, it will become 2 raised to 29 plus 2 raised to 29 if you do plus 1 operations, that which will be 2 raised to 30. So even after you do all the operations, this one number can become 2 raised to 30 and rest will stay 2 raised to 29 only. Even if you try your best. Now, if you take and of all these numbers, even if you take and of all these numbers, let's say the subset was they wanted of size n. If you take and of 2 raised to 30 with 2 raised to 29, 29, 2 raised to 29 again and again, it will again come as 2 raised to 29. Let's say m is equal to 1. So you only select this number in your subset. Still your end value is 2 raised to 30 at max. So our claim is that no matter what array is there and what subset you are selecting and whatever operations you do, your final end value will always be less than equal to, not even equal, less than 2 raised to 31. One case is 2 raised to 29, another case is 2 raised to 30, super, it's not going to go. Okay. So that's it. Now think in terms of vertical columns and the problem gets solved. So guys, see, this is the solution of the problem. Listen. So you can see that there are multiple different columns, right? Let's say the array given to you was this 1, 4, this is 9, 10, this is 11, right? This is 11 because this is 8, this is 9, this is 10, this is 11. Okay, 1, 4, 11, 10. So guys, you convert it to binary like this. This is 1, this is 4, this is 11, this is 10. Okay, I hope you can feel it. Now you will start from the last column. You will start from this last column, guys. Last column. Don't worry if you are not understanding something, because you might not have done the prerequisite course and my bit manipulation playlist. Complete that or do my course properly or come to our day live training, study from beginner level. Then you will understand what I am trying to say. So guys, the trick is that you start from the last bit. Last bit. 1, 4, 11, 10 looks like this. You have to select a subset of size 3. You have to select a subset of size 3 such that the final end value is maximum and you are allowed to do 5 operations. You are allowed to do how many operations, lovely people? You are allowed to do 5 operations at max of +1. So guys, my claim is that you should only focus on this column and you should try to select 3 numbers from here such that all of them are 1. Only if all of them are 1, then only 1 and 1 and 1 will come as 1 now for this column. We can solve the bit manipulation problem column wise. Okay. So guys, this is 0, this is 0, this is 1, this is 1. What is the end of all these numbers? End of all these numbers is 0. You have to select any 3 numbers. From these 4 numbers, you have to select 3 numbers whose end can come as 1. So what will you do? Simple. Whichever numbers are 1, you first select them. This is the first number I select. This is the second number I select. Now for third number, there are 2 options. This 0 or this 0. If you select this as the third number, you have to forcefully convert this 0 to 1. How many operations will it take to convert this 0 to 1? This full number is what? This full number is 1. You will have to make this number equal to 8. 8 looks like 1,000,000. When this will look like 1,000,000, then you can say a 1 is here. Okay. So, if you make this guy as your third number, then this number 1 you have to convert to 8. It will take 7 operations. It will take 7 operations. And if you convert this number as your third number, let's say this is your third number, it means this number you will have to convert to 8, because if you convert 0,100 to 1,000,000, then 1 comes at this position, right? So 4 to 8 only takes 4 operations. So you will take this as the third number, because to bring here 1 it only takes 4 operations, but to bring here 1 takes 7 operations, because this whole number you need to convert to 1110 so that 1 comes at this position, baby. So guys, the solution is pretty simple. You go and check the last column, and at the last column you try to achieve a AND value of 1. Why? Because if you can select here 3 numbers whose AND value is 1, we don't know the answer for the rest of the values, but it is sure that you can select a subset of size 3 such that at the last position of 1 will be there. And if you are able to bring 1 at the last position in the binary formation, in the binary representation, it means this is the largest AND value. Why? A number is bigger if 1 is there. Can you see? There is no 1 here. So it is 1. But when the 1 comes at the last position, the numbers become big. See, 4 and 5 have 1 here. Okay. So that's why I'm trying to, like in the actual question, I will make 31 columns. Column number 0, column number 1 till 31. Assume this to be the 31st column. And I will try that in the 31st one column, can I bring a 1 or not? If I cannot do it in less than equal to k operations, then I give up on that column. Okay. So guys, again reiterating the same old things. 0, 0, 1, 1. So what will be your algorithm? Let's say this is the last column. Let's say this is the 31st column, because the AND value cannot be bigger than 2 raised to 31 now. That's why. So for the easiness purpose, I am only considering the column number 3. But in actual question, you have to start from column number 31. Let's assume this is the last column here. Okay. You want to select three numbers whose AND is 1. That can only happen if all the three numbers have 1 here. So greedy approach. You will select this one, you will select this one, and the third one which is pending, you can either select this or this. Now which one will you select? You will select that guy which takes minimum operations to get a 1 year. So sometimes requirements can be different, guys. Okay, so don't get confused. Let's say this is the 31st column and the numbers are looking like this. Let's say you are told to select a subset of k something, you are told to select a subset of size 4. So you want to select 4 numbers such that the final AND value at this position should come at 1, because if one AND value can come 1 here, it means that the largest column you are able to bring 1. So this is the largest possible AND value for now. So obviously you have to select 4 values now. You will select this one, first value done. This is the second value. Now from where will you select the other two values? There are so many options. Which two zeros will you select to convert them to 1? Let's say the cost of this is 5, this is 10, this is 15, this is 20, this is 28. You will select these two zeros, the two zeros with the minimum cost, because to convert this zero and bring a 1 here, it only takes 5 rupees. To convert this zero and bring a 1 here, it only takes 10 rupees, baby. So guys, that's it. You go to the last column and you do this operation. Then you, whatever is the remaining number of zeros needed to make the select m numbers, check their minimum cost. Okay. If the minimum cost, total minimum cost is less than equal to k, it means you can put a 1 here. Now let's say it took total cost. Here 5 plus 10, cost is 15. And let's say cost is less than equal to k. So what you will do, you will put a 1 here and you will do k equal to k minus cost, because cost operations have been done. And guys, whichever numbers you have converted now, convert them in your mind now only. Here there were two zeros now one will come here, one will come here, and rest of all the previous numbers will be 0 0 0 like this. Okay, now a question can arise that why is this only the best way to do things? The two ones which were there, you kept them like that, and the minimum number of zeros I picked. First common sense is that you should try to select as many ones as possible now, so that minimum zeros you have to select, because if you select minimum number of zeros, the total cost will be minimum now, because zeros you have to convert to 1. Ones which are already 1, you don't have to spend any money on that. And the second deep trick is that, let's say this is 1, let's say this is 1. Okay, let's say this is 0, let's say this is 0. Okay, after 1, let's say this is the largest column, and here the 1 is 0, here it is 1. Okay, let's say this is 1, this is 1. Okay, let's say they told you to select 3 guys. How many guys? 3 guys. So if you select these 3 guys, what happens? Here you anyways have to spend money, nothing you can do. And these 2 guys you have selected. Okay, 1 0 you had to forcefully select, right? So after selecting this, what it becomes? A 1 comes here and rest of all these numbers become 0. Now think about the second largest column. For second largest columns also you would want ones here, right? Right? Because you selected ones here in the earlier column, now the same corresponding numbers here, there is a 0 and there is already a 1 here. Okay. But whichever zeros you select now, the zeros you select, they get converted to 1 here and zeros here. So they don't help you in any way for the second largest column. In the second largest, in the first largest columns, let's say you selected two zeros and two ones, okay, in the first largest column, to get the output as 1 for the end of three numbers, okay, or the end of four numbers, okay. Before going to the second largest columns, these both zeros are going to get converted to 1 and their corresponding numbers in the second column will be 0 because you're making them 1 triple 0 or 1 times 4 0, right? So when you go to the second column, these two zeros are not helping you at all. You will have to convert them to 1. But the guys which you already selected as 1, they could have been 1 0 or they could have been 1 1. Their values are not changing. So whichever numbers you selected which were 1 and their corresponding second column guys which were 1, they are actually helping because when you come to this column, you want, let's say, 3 or 4 numbers to be 1. One of them is already 1, reducing the number of operations. The zeros which you select in the largest column now, they get converted to 1 triple 0 or 1 10 times 0, whatever. So in the second column, they are all acting as zeros, not helping you. Because in the second column, there are so many zeros now, you'll have to convert them to 1, spend more money. But in the first column, whichever ones you selected, they remain as it is. So if those big ones in the second column, they have zeros or ones, wherever they have ones, it is helping you, baby. So I know no one is going to explain you this deep internal intuitional logic. This is a very hard level problem. And you should be solving it for 85 lakh rupees in your bank account. Anyways, guys, like if I was teaching this in my live session, I would be explaining this for 2 hours in too much detail. But because this is for the YT algorithm, I have to keep it short. So that's it, guys. That's the algorithm. You go to the first column, you try to select things in the way you want, the minimum operation. Then you go to the second column. But guys, there is a caveat. There are some corner cases. It can happen sometimes that, let's say, K is given to you as 10, M is given to you as 2, and when you convert all your decimal numbers to binary numbers, your vertical columns are looking like this. Okay, it is looking like this: 1 1 1 1 1 0 1. Okay, then this is looking like this: 1 1 1 0 0 0 0. Like this the numbers are there. Okay, so obviously you focus on the largest column because you want that in this largest column you are able to select two numbers such that their AND can come as 1. Okay, you want to select two numbers from the largest column such that their AND, A and D value, can come as 1. Guys, you will become very successful in my life. Just focus on what I'm teaching. You want two guys who to have value 1, but you already have two guys, this. Now what will you do? Now you have extra options. When you have extra options, now what you do is you declare this full set as eligible. This red part you select as eligible. They are eligible bachelors. When the everything is overflowing, you call them as eligible bachelors. What does this mean? This basically means that this basically means that you can select two ones from any of these 1 2 3 4 5 6 ones. Okay, so they are eligible. So obviously you put a 1 here at zero cost. Now, guys, when you go to the second column, now in the second column, you will only consider the eligible red ones which were there in the first column. So in the second column, you can only consider these numbers, this ones and these ones, same to same. You have to carry the indices while going from this column to this column. You have to carry which indices were eligible here. 1, 2, 3, 4, 5, 6, 7. So in the first column, the eligible indices were 1, 2, 3, 4, 5, 7. When you go to the second column, you again have to say that only these are eligible. Because if you, whenever you're selecting two elements, na, you can only select them from 1, 2, 3, 4, 5, 7. So in the second column also, you can only select from 1, 2, 3, 4, 5, 7. If in the second column you select this guy, it means this guy also needs to be forcefully selected because this is a single decimal number, na. But you cannot select the sixth guy because it will lead to a bitwise end of 0. So now at the second column, guys, again this, but. At the second column, now this, 1, 2, 3, 4, 5, 7 is the eligibility. But at the second column, guys, this is further going to shrink. Why? Here you again need to select two numbers which are ones. You can select only from this green part now. These three ones and nothing from the zeros, right? Why will you do that to increase your cost? So now for the second column, only these three are eligible, 1, comma 2, comma 3. So while going to the third column, you will say that only these three are there. Now you will check from here, which are ones, are they greater than equal to 2 ones or not? And one day finally that condition will come when there are not enough ones. And when there are not enough ones, guys, you will have to use this algorithm. You will have to know which extra zeros, and once you have done this, guys, this is the key, this is the most best point, the point where you do have to use some extra zeros. But guys, when you do it, everything gets fixed. At this point, you know exactly which m numbers are there. You know that 1, 2, 3, these are the m numbers. Now for all the indices further, you cannot change this. This is fixed because there is no other option. Greedily, you have gone through all the previous best options of the largest numbers. This is a very greedy optimal logic, guys. You need to feel it in your brain. Greedily, you have went through all the biggest largest options in the past and have constructed the best answer. So now you cannot do any changes here. Now all you can do is go to the further indices and just hope that these m options can get converted to 1 by the key operations. If you're not able to do this, give up and go to the next index and try to convert it to 1. See, let's say you're trying to achieve 1 at this index. If you have failed to do so, you try to achieve 1 at this index. The number will be small, but it will be the second largest. If you fail here, then try 100 like this. Okay. Hopefully you guys enjoyed it. Make sure you check the program link, guys. It has changed the life of many people and it will change your life as well. All you need to have is please have faith in God plus good health plus good mindset, Ram Ram, and get selected like my students. Love you all, Ram Ram.